for all complex numbers Z1 and Z2 satisfying mod Z1 is equal to 12 and mod Z2 minus 3 minus 4i is equal to 5. The minimum value of mod Z1 minus Z2 is number 1 0 2 2 3 7 and 4 17. Okay, right. And all of you know that mod Z minus alpha is equal to R always represents a circle with center at alpha and radius R. So the first one is a circle with center origin and radius 12, and second one is a circle with center at 3, 4 and radius 5. So that means you can have that is this is origin and 3, 4 and also the circle passes through, the second circle passes through origin. And radius 5. So now you can see that this is 2, 3, 4. So now you can see that the second circle passing to the center of the first circle and completely lies within the circle. So you can write that is mod Z, the second circle mod Z2 minus 3 minus 4i is equal to 5 passes through origin through 0 0 and completely lies within the circle mod Z is equal to 12. Okay, so therefore the minimum value of mod Z1 minus Z2 is equal to the difference of the radii, the difference of so this is 12 and that is minimum. So when this is Z1 and this point is Z2, so the difference of OZ1 minus OZ2, of course Z1 represents the point, Z2 represents the point, so that is nothing but 12 minus 10 which is equal to 2. 12 minus 10 which is 2 itself. So this is the difference minimum, this is the minimum value of mod Z1 minus Z2 means the distance between Z1 and Z2. So which is the total radius 12 minus the diameter of the second circle, it is 10. So the total is 12. So 12 minus 10 which is 2. So the answer is option number 2. Okay. See, mod Z1 is equal to 12, mod Z1 is equal to 12 అనే సమీకరణము మూలబిందు కేంద్రంగాను రేడియస్ వ్యాసార్థం 12 గల వృత్తాన్ని సూచిస్తుంది. అండ్ mod Z2 minus 3 minus 4 is equal to 5 అనే సమీకరణం 3, 4 బిందు కేంద్రంగాను 5 వ్యాసార్థంగాను గల వృత్తాన్ని సూచిస్తుంది. ప్రస్తుత ఇప్పుడు ప్రాబ్లంలో ఏంటంటే రెండో వృత్తం మొదటి వృత్తంలో కంప్లీట్గా ఉంటూ మొదటి వృత్తం కేంద్రం ద్వారా పోతుంది. కాబట్టి ఇది మినిమం వాల్యూ ఆఫ్ దట్ ఈస్ ద అత్యల్ప విలువ Z1 మైనస్ Z2 mod Z1 మైనస్ Z2 తాలూకు అత్యల్ప విలువ difference of that is 12, the radius of the bigger circle minus the diameter of the smaller circle. So that is 12 minus 10 is equal to 2 itself. We take a problem number 47. The least value of R for which the two curves arc z is equal to pi by 6 and modulus of z minus 2 root 3 I is equal to R intersect is 1, 4, 2, 3, 3, 2 root 2 and 4, 2 itself. And Rz is equal to pi by 6 అనే వక్రము and modulus of z minus 2 root 3 I is equal to R అనే వక్రము రెండు ఖండించుకోవాలంటే R యొక్క కనిష్ట విలువ ఎంత అని R యొక్క రేడియస్ R యొక్క కనిష్ట విలువ ఎంత అని. That means the least value of R for which these two curves intersect. So the options are 4, 3, 2 root 2 and 2. Now you can see that what is the 2 root 3i. So the center is simply 0, 2 root 3 and of course are these. Rz is equal to pi by 6 means that is tan inverse y by x is equal to pi by 6. So that implies y by x is equal to tan 30 which is 1 by root 3. Tan 30 is root 3. So therefore that implies tan pi by, all of you know the tan 30 value. Tan 30 value means sin 30 by cos 30. So that is 1 by 2 by root 3 by 2 which is equal to 1 by root 3. 1 by root 3. So therefore x is equal to y root 3. That is, so is a line that is Rz is equal to pi by 6 అనే వక్రం ఆర్జన్ గుండా పోతూ x is equal to y root 3 అనే సమీకరణం గల సరళరేఖ. x is equal to y root 3 అనే సమీకరణం గల సరళరేఖ. సో దిస్ ఈజ్ pi by 6. సో x is equal to y root 3. Right? So therefore, the minimum value of R touches the circle. That means therefore R is equal to modulus of, so this is the R value. So this is the line x is equal to y minus root 2. So therefore modulus of 0 minus 2 root 3 into 3 by 2 which is equal to 3. Which is equal to 3 itself. So the minimum value of R must be 3 itself. If the radius of the circle with center 2 root 3, 0 2 root 3 is 3, then the line touches the circle. And it will be the minimum value. Rz is equal to pi by 6 అనే సరళ రేఖ ఇచ్చిన వృత్తాన్ని టచ్ చేసిన అది వృత్తాన్ని ఖండించదు. ది మ్యాక్సిమం అది అత్యధికంగా అది దాన్ని స్పర్శిస్తుంది. ఆ వృత్తాన్ని స్పర్శిస్తుంది. కాబట్టి స్పర్శించాలంటే వృత్త కేంద్రం నుంచి దీని మీద లంబ దూరము వ్యాసార్థానికి సమానం అవ్వాలి. సో r must be equal to modulus of, by the formula, modulus 0 to root 3 into root 3 by 2, which is equal to 3 itself. So r is equal to 3 అయినప్పుడు మాత్రమే ఆ లైను ఈ లైన్కి దీనికి కనిష్ట దూరం వస్తుంది. 48. If z is a complex number, if z is complex and n is a positive integer, n is a positive integer satisfying 1 plus z whole power n is equal to 1 minus z whole power n, then z lies on the line x is equal to 0 to the line y is equal to 0, 3 line x is equal to 1 by 2, and 4 line x is equal to minus 1 by 2. And 1 plus z whole power n is equal to 1 minus z whole power n అయితే z x is equal to 0 రేఖ మీద ఉంటుంది, లేక నెంబర్ 2 y is equal to 0 రేఖ మీద ఉంటుంది, ఆర్ x is equal to half ఊర్ధ్వరేఖ మీద ఉంటుంది, ఆర్ x is equal to minus half ఊర్ధ్వరేఖ మీద ఉంటుంది. Right. Now solution is 1 plus z whole power n is equal to 1 minus z whole power n implies modulus of 1 plus z whole power n is equal to modulus of 1 minus z whole power n. So that implies modulus of 1 plus z is equal to modulus of 1 minus z. So that means z is equidistant from the points minus 1 comma 0 and 1 comma 0. That means this is minus 1 comma 0 and plus 1 comma 0. So this is x-axis, this is y-axis, origin. And you know that from 2 points, given 2 points A and B, the set of all points or locus of all points which are equidistant from both the points A and B is nothing but their perpendicular bisector. The perpendicular bisector of the segment A comma B. This is A joining B. So here, what is the perpendicular bisector? Y-axis. The perpendicular bisector is nothing but a y-axis, whose equation is x equal to 0. Whose equation is x equal to 0. So I will again, and it is known that the locus of the point which is equidistant from 2 points, from 2 given points A and B is the perpendicular bisector of AB. So here A is equal to minus 1 0 and B is equal to 1 0. So answer option number 2. Option 2 itself. Sorry. 1. Option 1. X is equal to 0. Z is equal to 1 minus t plus I into square root of t square plus t plus 1 plus 2, t square plus t plus 2, where t is a real parameter, on the curve. 1 x square plus 5 plus 3 by 2 whole square is equal to 7 by 4. 2 x square minus 5 plus 3 by 2 whole square is equal to 7 by 4. 3 y square minus of x minus 3 by 2 whole square is equal to 7 by 4. And 4 y square plus x minus 3 by 2 whole square is equal to 7 by 4. Right. So that means here, if t varies, then z varies. That's why I have written t is a real parameter. Means if t varies, z also varies. When t takes real values, then what is the curve on which the point, complex number z representing the point, lies? So the options are given. So now the solution is, let z is equal to x plus iy, so that x is equal to 1 minus t and y is equal to square root of t square plus t plus 2. So from this you will get t is equal to 1 minus x and y square is equal to 1 minus x whole square plus 1 minus x plus 2 plus 2. So that is, so therefore y square is equal to x square, here minus 2x minus x, so minus 3x, 1 plus 1 plus 2 plus 4. So this you can write as x minus 3 by 2 perfect, completing the perfect square, x minus 3 by 2 plus 4 minus 9 by 4. 4 minus 9 by 4. That means we have added 9 by 4 and subtracted 9 by 4. So this is nothing but x minus 3 by 2 whole square plus 7 by 4 plus 7 by 4. That is y square minus of x minus 3 by 2 whole square is equal to 7 by 4. So z lies on this curve. Actually, if you divide by 7, you will get a rectangular hyperbola, but that's not our bother. So the z lies on this curve. Y square minus x minus 3 by 2 whole square is equal to 7 by 4. So answer is option number 3. Z in x plus iy anukunte, x plus iy is equal to 1 minus 2 plus I into square root of t square plus t plus 2. So comparing the equating real and imaginary parts, x is equal to 1 minus t and y is equal to square root of t square plus 2. X is equal to 1 minus t anaga t is equal to 1 minus x. ఈ విలువను yలో ప్రతిక్షేపిస్తే y square is equal to 1 minus x whole square plus 1 minus x plus 2 వచ్చింది. That means y square is equal to x minus x square minus 3x plus 4. Now completing the perfect score, x minus 3 by 2 whole square plus 4 minus 9 by 4, which is nothing but x minus 3 by 2 whole square plus 7 by 4. So if you bring x minus 3 by 2 whole square ni ఎడం పక్కకి పట్టుకొస్తే y square minus of x minus 3 by 2 whole square is equal to 7 by 4. So answer జవాబు 3 ఆప్షన్, problem number 50. And z is not equal to 1. Z is not equal to 1. if omega minus omega bar z by 1 minus z is purely real, where omega is equal to alpha plus I beta, and beta not equal to 0, then the set of values of z is number 1 all z such that mod z is equal to 1, and 2 all z such that z bar is equal to z such that z is not equal to 1, and 4 all z such that z is not equal to 1 and mod z is equal to 1. ఇక్కడ మీరు z ఒకటి కాని కాంప్లెక్స్ నంబరు, ఒమేగా ఈజ్ ఈక్వల్ టు ఆల్ఫా ప్లస్ ఐ బీటా, వేర్ బీటా ఈజ్ నాట్ ఈక్వల్ టు 0, ఐ ఒమేగా మైనస్ ఒమేగా బార్ z బై 1 మైనస్ z ప్యూర్ రియల్ అయితే z ఉండే సమితి అంటే ది సెట్ ఫర్ విచ్ z బిలాంగ్స్ ఈ సింపుల్లీ ఆల్ z where mod z1 all z bar is equal to z means z real, and all z not equal to 1, that means entire complex plane accepting z is equal to 1, and that means z is equal to accepting the point 1 comma 0, and 4 all z such that mod z is equal to 1 and z not equal to 1. That means this is, you know that mod z is equal to 1 is a unit circle with center at origin, and on the entire circle except 1 0, all rest of the points come to this, satisfy this property. Omega, what you are given, omega minus omega bar z by 1 minus z is pure real, implies its conjugate is equal to itself. Omega bar minus omega z bar is equal by 1 minus z bar is equal to omega minus omega bar z by 1 minus z. Since z is real if and only if z bar is equal to z. Z is real if and only if z bar is equal to z. Now on cross multiplication, so that implies omega bar minus omega z bar into 1 minus z is equal to omega minus omega bar z into 1 minus z bar. Now simple multiplication. So that is omega bar minus omega z bar and minus omega bar minus omega bar z. Now 1 minus omega z bar plus omega z bar, just multiplication, is equal to omega minus omega bar z and minus omega z bar plus omega bar z bar. Omega bar z bar. Now see what are the terms you can cancel. Minus omega bar z here and here also minus omega bar z. So these two will cancel. Minus omega z bar and here also minus omega z bar. These two will cancel. Now what you are getting is, now you bring this omega to this side and take omega z bar to that side. So this implies omega bar minus omega is equal to z bar into omega bar minus omega. So taking omega z bar to the right hand side and bringing omega to the left hand side, omega bar minus omega is equal to z bar into omega bar minus omega. Now this shows that, now by hypothesis, omega is equal to alpha plus I beta, where beta is not equal to 0. That means omega is not real. Omega is not real. So when omega is not real, omega is not equal to omega bar. So therefore, you can cancel omega bar minus omega, and so that you will get beta alpha plus, since beta is not equal to 0, so for this purpose only that hypothesis is given. Since beta is not equal to 0, omega is not real. Is not real. So that omega bar is not equal to omega. So therefore, what you get is 1 is equal to z bar. 1 is equal to z bar, which is mod square, or mod z is equal to 1. So z belongs to the set. So therefore, z belongs to the set all z such that z is not equal to 1 and mod z is equal to 1. So now the answer is option number 4, I think. Right, option number 4, answer is option number 4. So here the z belongs to this set, unit circle. See, x-axis, y-axis, origin, radius 1. So except this point, z belongs to, z will take all the other values. So except 1 comma 0, z takes all the other values. That means z, if you want further I will explain for them. So I will write. So that is z lies on the unit circle with center origin at origin. Lies on the unit circle, except to include, if you want to include 1 comma 0 also, then z will be 1. But when z will be 1, this is absurd, because 1 minus z will be 0. So a finite number by 0 is meaningless. So that's why z is not equal to 1. So therefore, here you got entire unit circle except the point 1 comma 0. 51. You can take, if omega is equal to minus half plus I root 3 by 2, then the value of the determinant, value of delta is equal to determinant 1, 1, 1 and 1 minus 1 minus omega square and 1 omega square, omega to the power of 4 is 1 3 omega 2 3 omega into omega minus 1 and 3 omega square and 4 3 omega into 1 minus omega. Right. Now here you can see that the omega value is nothing but, omega is a cube root of unity. By hypothesis, omega is a non-real cube root of unity. Omega cubed is equal to 1 and 1 plus omega square is equal to 0. Now delta is equal to 1, 1, 1 and 1 minus 1 minus omega square means omega and omega square, and 1 omega square, omega power 4 means omega. Now expand it. Now expanding this one, so that is equal to 1 into omega square minus omega power 4 minus 1 into omega minus omega square. And all of you know very well this is the fundamental expansion of a determinant. By definition of the determinant, minus 1 omega into minus omega square plus 1 into omega square plus 1 into omega square minus omega. Omega square minus omega. So this is nothing but omega square minus omega and plus omega square minus omega plus omega square minus omega. So that indicates 3 into omega square minus omega, which is, if you take omega common, 3 omega into omega minus 1. 3 omega into omega minus 1. Right? So, correct answer is option number 2. Right now, problem number 52. This is also on cube roots of unity. If omega not equal to 1 is a cube root of unity, x is equal to a plus b and y is equal to a omega plus b omega square, and z is equal to a omega square plus b omega, x cubed plus y cubed plus z cubed is equal to 1, 3ab, 2, 0, 3, 3a cubed b cubed, and 4, 3 into a cubed plus b cubed. Okay? Right. Now, we know that again, by hypothesis omega cubed is equal to 1 and 1 plus omega square is equal to 0. So, by hypothesis, right. Now, x cubed plus x into xyz we will take. xyz is equal to, x is that, y is this and z is this. So therefore, x plus y plus z you take. X plus y plus z if you take a into 1 plus omega square plus b into again 1 plus omega square. Because a omega square. So if you take a common 1 plus omega square, b omega square plus b omega. So b into 1 plus omega square. So this is nothing but a 0. Because, and all of you know that, so therefore, all of you know that a plus b plus is 0, then a cubed plus b cubed plus c cubed is equal to 3abc. So therefore, x cubed plus y cubed plus z cubed is equal to 3xyz. So that is 3 into a plus b and a omega plus b omega square and a omega square plus b omega. So if you multiply this one, this is nothing but 3 into a cubed plus b cubed. Again using the same property. 3 into a cubed plus b cubed. So answer is option 4, 53. If modulus of z1 plus z2 by z1 minus z2 is equal to 1, then z1 by z2 is number 1 pure real, 2 plus side, 3 pure imaginary 4 Z2 by Z1. Z2 by Z1 itself. Right? So now we know that 1 is equal to mod Z1 plus Z2 by Z1 minus Z2. This is mod Z1 plus Z2 by Z1 minus Z2 whole square. Because it is 1. It is a 1 itself. Or if you want, I will scrap this step. 1. So this implies this is equal to Z1 plus Z2 into Z1 bar plus Z2 bar by Z1 minus Z2 into Z1 bar minus Z2 bar conjugates. Bar means because mod Z whole square is equal to Z into Z bar. So now cross multiplication you will get. So that implies Z1 plus Z2 into Z1 bar plus Z2 bar is equal to Z1 bar, sorry, right, Z1 minus Z2 into Z1 bar minus Z2 bar. So now expand, multiply. So this is Z1 bar plus Z1 Z2 bar plus Z1 bar Z2 plus Z2 Z2 bar is equal to Z1 bar minus Z1 Z2 bar minus Z1 bar Z2 plus Z2 Z2 bar. That is. Now you can cancel this. So this Z1 bar and this Z1 bar will cancel, and this Z2 bar and this Z2 bar will cancel. So if you take this -1 to this side, so that indicates 2 into Z1 bar plus Z1 bar Z2 is equal to 0, or Z1 bar plus Z1 bar Z2 is equal to 0. So this shows that Z1 bar by Z2 bar, Z1 bar by Z2 bar is equal to minus Z1 by Z2. Okay, Z1 bar by Z2 is equal to minus Z1 by Z2 bar. From this you will get. So therefore, Z1 by Z2 is pure imaginary. Because you know that Z is pure imaginary if and only if Z bar is equal to minus Z. Pure real if and only if Z bar is equal to Z. So the correct answer is option 3, problem number 54. 54 is, if modulus of Z minus 1 is equal to 1, then Z minus 2 by Z is equal to 1 I 2 I into tan of half RZ 3 minus I into tan of half RZ, and 4 I into tan of RZ. That means if Z lies on the unit circle with center at 1, 0, then the value of Z minus 2 by Z is equal to one of the 4 options. And you know this is z minus 1. So first of all, z lies on unit circle with center enter at 1, 0. Okay, right. Now here, now let z is equal to x plus iy. So that mod z minus 1 is equal to 1 implies x minus 1 whole square plus y square is equal to 1. So that implies x square plus y square minus 2x is equal to 0. Give a reference number 1. So that is the hypothesis you are given. If z is x plus iy, then the x and y satisfy the relation x square plus y square minus 2x equal to 0. Now we take z minus 2 by z. So that is x minus 2 plus iy by x minus iy. And so this you can write as x minus 2 plus iy into, x plus iy z into x minus iy by x square plus y square. So this is now simplification, just x into x minus 2 minus iy into plus iy, minus I square is 1. So plus y square plus I into, now come on see, plus I into y plus I into xy minus y into x minus 2 whole by 2x, because x square plus y square is equal to 2x. And all right, I will instead of here both I will simplify and write it. So that is, now this is y square plus x square minus 2x plus I into what you get is 2y by 2x and y square plus x square. So this is equal to 0 plus I 2y by 2x. This is by 1. So which is equal to y by x. And y by x is nothing but arg z. Since arg z is equal to tan inverse y by x, we have z minus 2 by z is equal to 2 will cancel, y by x is tan inverse, is equal to I into tan of arg z. I into tan of arg z. So that is the problem. So that means the correct answer is, what is the correct answer? So fourth option is the correct answer. Okay, right. So now you go to the problem number 55. Is if or the value of e to the power of I into 2m cot inverse p, pi plus 1 by pi minus 1 is equal to 1, then, is equal to, this is equal to 1, p plus 1 by p minus 1, 2, p plus I by p minus I, and 3, Now you can see that is, so let cot inverse P is equal to theta, so that cot theta is equal to P. So therefore, we have e to the power of I into 2m cot theta, 2m theta into P. Now substitute the value of P here. Cot theta, I cot theta plus 1 by I cot theta minus 1. So this is, and you know that e power I theta means cos theta plus I sin theta. So this is cos 2m theta plus I sin 2m theta into, now write cot theta as cos theta by sin theta. So that is I cos theta plus sin theta by I cos theta minus sin theta. And all of you know that e power I alpha means cos alpha plus I sin alpha. That is. So now if you simplify this, now I will write this is, instead of writing every time that one, I will write cis 2m theta, because cis theta means cos alpha plus I sin alpha. Cis 2m theta into, now what you get is cos, cis 2m theta. Here you take I common from numerator denominator, I into cos theta minus I sin theta by I think that power m, okay, that power m. So this power m, cos theta minus I sin theta by cos theta plus I sin theta whole power m. Here if you take I cos theta, then you will get I outside, cos theta plus I sin theta. So this I will cancel. So this is cis 2m theta into cis, this is minus cis 2m theta into cis minus 2m theta. Since cos theta minus I sin theta by cos theta plus I sin theta is equal to cos theta minus I sin theta whole square by cos square theta plus sin square theta, which is 1. So which is nothing but this is cis minus 2 theta. So whole power m is there, so minus 2. So this shows that cos 2m theta minus 2m theta, if you multiply, and everybody knows cos 2m theta minus I sin 2m theta plus I into 2m theta minus 2m theta, and this is 0 and this is 1, cos 0 plus 0, which is equal to 1. So here you have used a simple thing, e power I alpha is cos alpha plus I sin alpha, and you know that cos alpha plus cos beta into cos gamma plus cos delta, the angles will be added, and if you divide it, the angles will be subtracted. So that's why here see cos 2 theta minus I sin 2 theta. Answer is option number 4. So the value of this is nothing but 1. Imaginary part of 2z plus 1 by iz plus 1 is equal to minus 2. Then z lies on 1. The circle mod z is equal to 1, 2 on a line on a line, or on the line x plus 2y minus 2 equal to 0. 3. On the line x plus 2y plus 2 equal to 0. 4. On the ellipse, x square by 4 plus y square by 2 is equal to 1. Now this problem also needs simplification only. Now let z is equal to x plus iy. X is x plus iy. So therefore 2z plus 1 by iz plus 1 is equal to 2 into x plus iy plus 1 by I into x plus iy plus 1. So that is 2x plus 1 plus iy by, so this is, you will get 1 minus y plus ix. 1 minus y plus ix. So this 2x plus 1 plus iy into, multiply numerator denominator with the conjugate, 1 minus y minus ix by, you will get 1 minus y whole square plus x square. Right. So that is equal to, now we will simplify and separate the real and imaginary parts. So this is, and we want 2x plus 1 into 1 minus y, 1 minus y, and plus xy. So this is the real part in the numerator, plus I into, now come on, I into y into 1 minus y minus x into 2x plus 1 whole by 1 minus y whole square plus x square. Right. Now see, this is the real part and this is the imaginary part. But you are given that imaginary part of this is equal to minus 2. So therefore, y into 1 minus y minus x into x plus 1 by this is equal to minus 2. Since I am of 2z plus 1 by iz plus 1 is equal to minus 2, minus 2 implies y into 1 minus y, y into 1 minus y minus x into 2x plus 1 by x square plus 1 minus y whole square is equal to minus 2. So this implies y minus y square minus 2x square minus x is equal to minus 2x square minus 2y square plus 4y plus 4y. Now see what are the minus 2x square will be cancelled. So if you bring to the side, this is y square, okay, 2y square, this is y square, minus x, y square, 4y minus 3y minus x is equal to 0. If you equate the imaginary part, so from this what you get is, so therefore imaginary part of 2z plus 1 by iz plus 1 is equal to, if you simplify this one, or is equal to, I will write, is equal to minus 2 implies 2y into 1 minus y minus x into 2x plus 1, 2x plus 1 by x square plus y square minus 2y. So x plus 2y minus 2 is equal to 0. So z lies on the line x plus 2y minus 2 equal to 0 itself. Here the only is you have to take care of the simplification only, no techniques, no use of mind, just arithmetic part, calculations. So if imaginary part 2z plus 1 by iz plus 1 is equal to minus 2, then z lies on this line. So that means, see what is the option? X plus 2y, 3, sorry, number 2, option number 2, answer is option 2.